Well, hi, and welcome to my shop. Thank you so much for joining me here. It's the day after Christmas, December 26th. And in Canada, we call this day Boxing Day. I don't know if anybody else in the world calls it that. But, years ago, Boxing Day was a huge crazy shopping day here in Canada. And I don't think that happens so much anymore. Now there's all kinds of other days, Black Friday and everything else you can think of. And I don't think anybody's out shopping this year on Boxing Day in Canada. So now, this radio, I ended the last video having discovered some interesting stuff about what happens when you turn this control here. This control that is labeled oscillator. But it sure didn't seem to be an oscillator. I used my SDR radio to pick up signals coming out of the radio as this was turned, and it was pretty clear something was happening, but it's also quite clear it's not really an oscillator signal. So let me just clarify it here. So when we look across on my SDR, you see various noisy signals here like this. And then somehow, as I tuned this radio, something was happening where you could see a peak. Now this is hard for me to draw on a piece of paper but it would start about here. And what's happening is everything in this area is boosted. So as I move this peak forward, as I tune this knob here, let's say this got all the way to here, this thing, which I drew terribly, would then leap up as the tuning point went by. That's an indication of a resonance, not a oscillator signal, a resonance. An oscillator signal, by the way, would have looked more like a straight line going up, and it wouldn't have affected any of these existing signals and noise things at all. As I tuned across, this would just be moving along like this. It wouldn't have this effect. So why is that? Why is it that turning a knob labeled oscillator appears to tune the radio or do something? And it's possible, because I don't understand this radio yet, really. Certainly the oscillator portion I don't understand at all. The rest of it's pretty straightforward, but the oscillator is very unusual in here. And this is one of the earliest radios to attempt to heterodyne signals. So it's called a super heterodyne, by the way. The word super means beyond your hearing, because there were earlier heterodyne radios that heterodyned right in the audio frequency, and what that's all about I don't know. So that's where the word super comes from, because it's beyond your hearing. In this radio it's 100 kilohertz. Now let's think about that for a minute, because the paradigms in my head from regular radios of course include 455 kilohertz for an IF, but this doesn't have that. So when I was tuning this and seeing that resonance point go back and forth through the AM band, I'm thinking, well, this is like tuning the radio directly here. But really, if the IF is only 100 kilohertz, which it appears to be something like that, 75 in fact, it looks like more like it's 75 in here, then the local oscillator is running just a little ways away from the tuned signal. So you have your tuned signal here, you have the local oscillator here, 100 kilohertz in between. And so this local oscillator pretty much sweeps through the AM band. And that's what that resonance was doing. It was sweeping through the AM band. Or was it actually sweeping 100 kilohertz higher? So what I'm thinking is this resonance thing that I picked up with my SDR is really the resonance of the oscillator changing to change the frequency. But the oscillator is not oscillating within that resonance either. The Q of the resonance circuit's not high enough, or there's something wrong. I'm sure there's something wrong in here with the tube and the coil and that kind of stuff. That's the only way I can reason out why tuning this would show a tuned resonance traveling up and down the broadcast band. So assuming that's correct, that it wants to oscillate it but it can't, what would I do next? So we could leave the oscillator for a minute, and we could work on the very front end of the radio, but I don't think I want to just yet. We could try to pass an IF signal through the IF. and see if it gets all the way through. We could then align these a little bit, align these transformers here a little bit. Well, what if the radio is actually working and I'm just so inexperienced with this I don't even realize it's actually a working radio at this point, and it would receive something if I only tried. Wow, chances pretty small of that, aren't they? Well, you know, what would happen next in a radio that's working is you would do an alignment on it, and just to try to peak the performance up. The tube's barely held in there. There could be all kinds of problems in this radio that we haven't discovered yet. So maybe that's the name of the game. There's all kinds of problems I haven't discovered yet. No use thinking too hard. I continue some kind of process that will enable me to discover more problems. Surely trying to pass a signal through the IF is going to be some kind of thing. Some kind of eye-opener is going to happen here. So if we wanted to do that, I remember everything I've got set up here. That's the B plus meter over here. And this box of tubes doesn't need to be here. So I'm going to want to inject a signal of known frequency and at 100 kilohertz. So I think I'm going to continue to use my my sweep here. Yeah, well, why didn't I try sweep? Well, you know what? Duh. I'll use the sweep generator here. Put a sweep signal through and just peak it up, and we'll watch what's coming out the far end. That's the way to do it. I'm going to get that all set up here. I think I know what I'm doing now. Thanks for your help. Yeah, I did say something about setting this up would highlight problems for me, would make me spot problems. So here's one. So I pulled the tube out of here because this tube is the first tube after the detector, and it's got a problem in that the plate voltage gets to it through the primary of this primary is open. So there'd be no plate voltage, so no reason to have a tube here, so I pulled it out. But then I realized, wait a second, this is the grid leak detector, and it's looking for a tube. It needs the tube grid to do its job. So how can I get this detector to work without a tube in here? I'm not so sure I can't. I think I need to put the tube in here, and then somehow I have to get a B plus onto its plate. Now is that just a matter of you know, shorting these out? There would be no plate resistance if I did that. So we need some kind of plate resistor here to basically replace the resistance of the primary here. These are amplifying transformers. So the secondary I was able to measure at 5, 6, 7 thousand ohms. And I think they multiply by 5 or so. So could I just simply say what's 5,000 ohms here is probably going to be 1,000 ohms here. If I put a 1,000 ohm resistor in here, I'll be able to energize the plate on this tube. I don't really care about the output. I don't really care what happens to it. Not at this point. But it would be sitting on this resistor. But really I want to listen to the grid. Now the other thing is hooking this up. So this is going to my signal tracer. I'm going to use it as an audio amplifier. You know, this should work. The input impedance here is extremely high. 10 mega, more than 10 megohms. 100 megohms, something like that. So this should probably work. I just have to have this, and I gotta have this. I gotta have that. This, that. Oh, and the other thing. Okay, I think we're just about ready here. Let me just review everything. This is for my own sake too. So this meter is going to measure the voltage that's being applied to the filaments. So this meter should go full scale. It's on the 5 volt setting. It should go full scale. I'm supplying this with about 5.5 volts, in fact, just a little extra. This guy up here is going to measure B plus. The B plus, gee, I don't think I really set it. The last time I applied B plus, I just did enough to make one tube work, and then I just stopped. So I don't know where we're going to set that. The radio itself is calling for 45 volts on the particular line that I'm supplying, so that's 45 volts for the plates of these tubes. I have installed a 1000 ohm resistor here because of the open primary, and I've also connected a lead to the tube side of this resistor, and it's going out to my signal tracer, which should have made a noise there. Why did it not make a noise? There we are. So we can listen to any audio that might come out of here. I was going to try to use my signal tracer and listen to the IF through here. The IF, I think, is at 75 kilohertz. My signal generator only goes, signal tracer only goes down to 170 kilohertz. It doesn't get anywhere near, so we can't hear it. Unless I'm completely wrong about what the IF frequency is in here. Okay, I think we're ready to go. Oh, no, we're not. We still have more. So I have the sweep generator running here. It's starting at 50 kilohertz and it's stopping at 200 kilohertz. So it's crossing the 75 kilohertz line, and then it's running the sweep on the scope here. A little hard to see in this camera, but I have another camera for the scope so we can get a good look at what's going on there. Just center this just a wee bit. There. So the 100 is going to be somewhere in here. It won't be in the middle. That's 50 to 200, so you can kind of imagine where 100 should fall. Or 75. 75 or 100, I really don't know. We'll probably find out more right now. Okay, next step is to fire up the tube heaters. Okay, to do that I have to open them here. And we're going to turn on the this guy here. Okay, so he's producing the 5 volts. He has a cooling fan, unfortunately. It just adds more noise in here. Now, why didn't that meter come up? Why didn't that meter come up? And why didn't these tubes turn on? Oh, I don't have the switch closed, for crying out loud. That's right, okay. We will now operate the switch here. A little awkward. Wow, okay, so the tube's turned on. How come that meter didn't come up? This is not a good situation to be in. How come no action? You know why? Because it's plugged into power bars that are not turned on. That's why. So I turn on my lower lighting system here. Okay, see how that red light's on. The meter will come up and go full scale. Might do something funny first. Oh, there it is. Okay, so we're at 5 volts. So everything's good. This tube seems way brighter than it was, but it's just my imagination, I'm sure. Now, next thing. So the sweep is happening. The scope is connected to nothing. I didn't connect the scope to anything. Okay, so that's interesting. What do we want to scope with this? What if we try to look at what? Put this on the ground, or the return, or whatever it might be called. Okay, and then I'm going to clip on this transformer. What will it do? Let's look. See, doing something there. Now the connection of this might disturb. This doesn't look right at all. There's some kind of radio noise there. Whoops. Here, have a look. It's a little hard to see in the camera, but this is just a fuzzy line here. I'm going to tune the radio and just watch what happens, just in case something happens. Absolutely nothing is happening, I can see. But we probably don't have the oscilloscope really in the right place. Let me go back to the first transformer here. Instead of the second, I'm on the primary side of the second IF transformer. I'll switch to the primary side of the first. Wait a minute. Okay. I go here. Now, I saw a nice resonance that I was able to so this is the turning the knob called mixer, and it's having some kind of effect there. Not much. And then the this is the oscillator control, doing nothing that we can see on the scope. Okay, now the thing is, I'm sweeping this, come to think of it, I'm sweeping it with a signal that's not modulated. So let's put the scope way at the far end where the detection is supposedly happening. Down here where I have the audio connected. So this is the handy, not so handy ground connection right there. Very short lead on my guy here. Can I make it down there? Cannot make it there. So we would want to be on the well, we'll just try different things here. I don't think this is going to work. Not going to work. Okay, so a ground point can be here. And then now we'll put this on the output of the transformer going to the detector there. So we see the same oop, you don't see anything there. Basically it's the same schmozzle. What I'm going to do is I'm going to stop the sweep. Oh, that stops the sweep on the where's that coming from? Oh, that's coming out of the signal tracer. Let's start it up again. I must have just a loose wire I was banging here that was making that sound. That's all. So we're never going to hear anything unless I put in a proper signal here. I think we're getting nowhere with the sweep. We're getting absolutely nowhere. So what I'm going to do is I'm going to switch to a different signal generator, fixed frequency signal generator back here. Switch to that. Oh, okay, hold on. No, we won't switch to that. I missed something here when I was setting up. This is the output from the sweep generator. It doesn't go anywhere. You have no output from the sweep generator hooked up to anything. So that might explain a fair bit right there. So we want this output. Well, what have I got hooked up? Oh, I know what I've done. I've got it hooked up to an outdoor antenna. That's what's going on. Okay, let me hook it where I want it. Hold on, just momentary confusion's going on here. Okay, output down. I'm feeding the sweep signal into the radio for the first time. On the scope, I'm still looking way down at the far end here. I'm going to move it upwards a little earlier. Let's try it here. This is basically the first transformer. Still not seeing anything interesting on the sweep. Why could that be? It could be maybe something like that. Oh, now that's doing something, not much. Nothing happening with that. Ooh. You know, this is clearly doing something now. My scope is on AC input, so the DC is being nulled out by a capacitor. That's why you see it doing what it's doing. Let's not put this too far from where it was. I don't know what this control is supposed to do. Volume. Okay, I do know. It's supposed to be volume. So we have an unmodulated sweep going in, but we should see it on the scope. The sweep maybe is not going in. The sweep has got no output power. That's what it is. I never turned it up. Okay, wait a minute here. Let's just do this. Okay, so let me give you I'll give you the scope view. We're watching for a peak to show up. When I do this peak, maybe in this area. Okay, so I'm going to give it a pretty good chunk of power here. Come on, show me something. Nothing showed up. Let's go. Giving it the works. Okay, so there we have it. It's way down here. The resonance is off there, over there. We got some funny business right in here too. Lots of funny business in here. Don't really know why. For sure this is sweeping. Let me just check the stop frequency is 50. Look at 50 kilohertz. I'm on the first transformer. I've hooked up a scope. Maybe that's throwing it right off. If I didn't have the scope on, this frequency would move up. And sweep, the other end is 200. So we're still 50 to 200. I really thought there'd be a peak in here. Let me tuning the oscillator control, turning the mixer control. Okay. Moved my scope connection to the other side of the. I'm going to try anyway to the other side of the primary coil. Just discovered there's a wire completely loose in here that I was just relying on a wire that was loose for the scope connection. Okay, that might have been a bit of a problem right there. Let's just repeat what we were doing. No, it looks exactly the same. Okay, other side now. Oh, there we go. There's something interesting there. Okay. So this is the first IF transformer. And wow, what exactly do you say about that? Okay, let's tune the radio. So I'll tune the oscillator control. Nothing happened. Okay, I'll tune the mixer. It's pretty happy about where it is, isn't it? And now I'm going to turn the adjustment of the trimmer for this transformer. Okay, I'm in there. I'm moving the trimmer. Oop, I touched the wire there briefly. Seems to make it bigger, but not any different in frequency. Well, that's okay. So I'm gonna go there. Let me put the camera on this one. So what I'll do now is I'm gonna move the scope connection from this transformer up to this one. So now we are past this tube. We got 2 tubes, 2 transformers. Well, what do we got on the scope? We got, oh my, we got that. Okay, I've tuned some things here. Anything changing? Nothing is changing. Not significantly anyway. And the oscillator control has no bearing on this at all. It really looks like this is resonant way below 50 kilohertz. That doesn't make sense. Or is it way above now and I don't see it? Way above, way above. I think I can do this. No. Way above, way above, way above. So now the sweep is stopping at a megahertz. So that's all the way from 50 kilohertz to a megahertz, and pretty clear. There's nothing else in there. Let me tune the trimmer on the second transformer and see what we get here. Okay, here we go. That's me touching it by accident with my hand. Nothing really happening. I got things to happen when I tested it before. Let's go further down the line here. Go down to the next. Go to the next transformer. Let's just keep going down the way and see what happens. It's a little different. So there's like it necks down to almost nothing reading here. It's a little hard to see on the camera. So it's a very, very strange looking thing. Okay, tuning different stuff. Nothing happening. You know, it does happen a little bit there, doesn't it? Seems to get a little weaker. So that's the mixer control. Well, let's go another one. We'll go another one further down the way. Having more and more trouble finding a valid negative to connect to here. Okay, I have to revert to a flip read. So what I'm doing is I'm extending the ground lead on the scope. So I can get a little further. Okay. Now, so the one we just tested, that one, okay, it's exactly the same. And then we'll go to the next one. Oh my gosh, look at how different that is. So, yeah, I explained all that. Tuning stuff. Nothing happening. So this is 50 kilohertz. 100 might be. Oh no, we're up at 1 million here, aren't we? We're running up at 1 million. Let me bring this down here. Okay. Just check the stop frequency now is 200. That's 200 out here. 50 here. This looks more like a low pass filter. How flat this is. Yeah. Well, I can start to sweep a little lower. Can I? I don't know. Yeah, I can go even lower. So this is stupidly low now, this frequency. It's just not at all the shape I would have expected. Just darken it a wee bit more. Yeah, it's just really hard to get these things on camera. Well, I've ended up with a result that I A, can't explain, B, didn't expect, C, don't know what to do about. So I think what I'll do is I will revert to the other signal generator because it has it's modulated. So we'll stop with the sweep and go with the fixed frequency. See what we get out of that. Okay, so all I have to do is transfer the input to the radio from this signal generator over to this one here. Okay, that's pumping out a fairly strong signal right now. And what are we getting? There's nothing on the scope. So we're way up at 1400 kilohertz. We really want to be trying to feed, assuming the oscillator and all that stuff is not really working, we really should try to hit this with the IF frequency itself. And then watch to see what happens on the scope here if I hit it. Okie dokie. Here we go. Oop. That's 450, 400, 300. I can only go down to 300 here. I'm going to go one lower. Okay, so that's 95. That's 95. I don't see anything on the scope. 95, 100. So, the scope's not the right thing to look at. Scope, no, not the scope. Not the scope. We should be listening. We are listening. Are we listening? So that hum is the hum of my signal tracer itself. Maybe coming out of here somehow too. I have it turned right up. Let's turn some controls here. Just who knows, right? Who knows? We're looking for a discovery. Maybe the scope is wrecking things. The scope connection. You don't need it. Let me get rid of it. Modulation is 1,000 hertz. Fairly hefty signal going in there. Well, certainly nothing to be heard. Not surprising. I mean, if this worked, I would be stunned. I really would be. So we can't listen with the signal tracer to anything under 170 kilohertz. That's really a drag. I have to use the SDR. I have to use the SDR to see what's going on here. Okay, I gotta stop and figure out how to use the SDR now to see what's going on here. Okay, so I've been just fiddling around here. That tone you're hearing is coming out of my signal tracer. My signal tracer is listening to the output stage of this radio, and that's what it's hearing. And I got there for reasons I don't understand, so I turned the camera on see if we can sort this out. What I did was I stopped the sweep generator from sweeping. It's at a fixed frequency now. The frequency is 4 kilohertz. That sounds like 4 kilohertz, come to think of it, doesn't it? Doesn't that sound like, that sounds like 4 kilohertz. So it seems to me what I'm doing right now is I'm simply putting an audio signal through all these tubes. It's right at the limit here. Let's go a little lower if I can do it. I can do it this way. Oh, that's 400 hertz. 400. Yeah, that's all that's going on. Well, okay, so it'll amplify an audio signal. It'll do something. So you think if I just can raise this signal to the IF frequency, it would go through those transformers and we would hear it again. But not from here. In fact, how can we hear this? There's no, oh yeah, no modulation. It's the actual carrier signal we're listening to. Okay, that was bogus. I'm trying to hook up to the grid of what is the first audio tube here. I think what I'm actually, so I'm listening to the plate. Oh my god, you know what? How stupid can you get? What a dummy. So I've done all this without these tubes having any B plus on them. And we actually got somewhere with no B plus. Oh my gosh, how crazy can I be? Okay, let's take care of that. Duh. Okay, that's on. Now, it's on standby. The positive is coming down here to the 45 input, and the negative's going to the negative. We want to put 45 volts on here. This is the voltmeter to show us 45 volts. 45 volts, just about full. Just about full there. Now while we do this, we certainly want to be listening to the radio, which we are. And what are we listening to going in? Nothing. So let's just clip this way at the front end here. I'm going to put it way up here. Grid of the very first tube. Grid of this tube. Fairly heavy signal. Let me knock it down 1,000 hertz. Okay, now we're ready to start bringing up some B plus voltage here. Let's see what happens. That was interesting right there. I turned down my signal. Tracer a bit. So get my ears blown off. Here we go. Hear a thing yet? So we're at about, we're halfway there. Okay, let's hold it here. That's 45. Tune. So wild things are happening on the scope. That's a short happening in there, I'm sure. But at least we're hearing stuff now. Look at the scope. I think it's. Now I have. What do I have? I have the signal generator, not the sweep. And look at that. No idea what it is. Okay, let's try this one. This is actually ahead of the incoming signal. So it's actually not, like the signal's not going through this part. I jumped it in early. So maybe a mistake. You see nothing. And we hear nothing. So again, no mixer. Let's just fool around and look for some kind of IF frequency sensitivity or some more. Come on, baby. Weren't you making big noises here? I still have the voltage. What to make of that? So I'm turning the oscillator control. I seem to be tuning this in. Keep your eye on the scope. You can see some interesting stuff happening there too. It's definitely the audio from the signal generator. Yep. So right now this is receiving and detecting the output of this signal generator at 175. 175. So my guess is the proper IF in this thing is 170. One of the reasons for that is my signal tracer goes to 170. Okay, so is it really coming through these? Ooh. That's my hand touching this. I'm using a terrible tool to do this. None of them seem to be making much difference, but then I'm just listening. Yeah, they don't seem to make much difference. Oh, that did. So, so I'm peaking at a 175. I don't even know if that's correct. Now, is this thing by any chance a radio at this point? Is it actually working and I just don't realize it? No, I can't. Can it? I can't possibly be doing that. So I'm going to put an antenna in place of the signal generator. Doesn't make any sense. Any real... I don't want to think about it too hard. Ground on. Yeah, when this antenna is not switched. Feeding it right into the grid here. Yeah. And dry stuff. Yeah, if this thing started picking up stations, I would probably pack my shop up at this point and walk away. Especially since the antenna is not even switched on. So I'm gonna, oh, what's been going on all over the, oh my gosh. Okay, we gotta stop now and take a look at this. We don't have to stop. Just take a little look at this. I'm just paying no attention to this. And I'm turning the tuning knob. Check it out. What's going on? So now that is an oscillation for sure. Two of them. Two oscillations. They're probably one's exactly double the other. So we'll set it one at 17, the other one's at 14, so one is double the other. So if I go all the way down to the bottom, it gets down to about 500 on the lower one. They go all the way up to the top, way up there, but much stronger. Well, that's definitely an oscillator there, as opposed to what I saw last time. And it's a strong oscillator. Okay, so if 175 is the IF and the oscillator runs above, then you'd want this to stop somewhere around here. This would be tuning in 600. But it goes all the way down to here. But that's not to be too much of a concern, because it goes way up and beyond. Way beyond. Not way beyond, but beyond. Beyond by, well, a little over 200. That's close. Well, if that's really the local oscillator operating. And where am I picking this up? I'm picking this up. This is the output of the last RF tube. Just before, this is going into the detector. It's literally heading for the resistor capacitor detector, grid leak detector. Well, if we have an oscillator and we can make a signal into the radio, like for instance, if I set the oscillator to 1 million here, and we think the IF frequency is 200, I fire in an 800 kilohertz signal. If the radio is working, we will hear it. Is this radio working? I'm going to find out. Okay, so right now I've got an antenna connected. I'm going to disconnect the antenna. Not even a complete antenna. Didn't seem to do anything. Good. And then I'm going to hook up the, not the sweep. Why wouldn't I try the sweep on this? Let's try the sweep on a counter. I have this on the SDR right now. It just takes a second to do that. Now, up on the signal. So we're pumping a sweep signal into the array. No, we're not. It's not connected. Okay, back onto the grid of the first tube. Let me just turn down the output here. Okay. So, oh, son of a gun. So it's like an audio rolling through the tubes that are designed for RF. That's what that was, I think. Now we'll turn up the sweep. Oh yeah. It's coming out of the speaker. And I also don't have the pickup coil in any kind of useful position here. That's also another problem. Let me move the pickup coil. And then I'm going to show you what's on the scope. Some wild stuff on the scope. Okay. I'm going to dip this close, and you see a signal going way up there. Alright, right at a million. That's the million. That's the million. That's the million local oscillator. I'm going to put this where? I put it. I'm just putting a pickup coil somewhere where it's going to sit stable. There. Now, I'm jamming in a signal. I thought I was doing it at 800. No, I'm doing the sweep. You have the sweep running, starting at 50, ending at 19. That's no good. Just going the wrong way here. 200. Oh, loose wire. Loose wire. Okay, stopping at 100 right now. Oh, yeah. Oh, hello, everybody. Welcome to my shop. So that came out of my signal tracer, so that's what's coming out of the, let's turn this down. Turn down the input a long ways. So I'm going to show you what's on the scope here. You know, I'm going to stop and get a better screen going. Okay, let's see how this does. Now, I got so much stuff here, I don't know what I'm up to anymore. So, we're feeding the sweep signal. The sweep signal appears to have no effect here. So you can see I'm adjusting the signal level. Big effect on the scope. And that's not a rectified or detected signal on the scope. That's before the detector, which is probably why it's swinging high and low. Tuning the radio now. Yeah, and don't tune the radio. Tune it back right on the million. 800. So we want to be putting, while we're sweeping, why the sweep just isn't really responding on there properly. Why is that? Have I done something wrong here? The ground, the sweep input is going right into the grid of this tube. It made lots of noise when I hooked it up. I'm going to move the scope to the other side, if I can, of the detector, and then we'll see if we're seeing a detected signal. At least we can do that. You can see something on my scope, but the scope lead is not actually connected to anything. Very, very tricky in here. Get out of there. Got it. So that is the effect of the detector. That kind of went away. This was deeper than this. Out of adjustment, maybe. Bad connections. So that's probably as good as the detector gets in a radio like this. And why it's jumping so much, I don't know. Who knows what's going on here? The radio itself seems pretty not so stable. Okay, I think it's the scope connection itself. Good enough. What do we got? Okay, let's tune this baby. What happens when we tune it? What happened there? Explanations? Don't look at me. This is ahead of the deal? Oh, it's still having an effect of some sort. Maybe it's not completely ahead. It sure looks like it. Must be some kind of involvement still through here. Getting the right kind of look on the scope. I'm not getting the right kind of look on the SDR. What did I do with the SDR lead? I'm starting to mutter. Let's put it over here. So if the radio's local oscillator is at 1,000,000, but the radio's really trying to receive, let's guess, 800 kilohertz, then there should be some front end visible tuning. No, not on this radio. Not the way it is, Jim. Come on. I have to try to feed the signal through this coil. Hey, why don't we try that? What happens if I actually try to feed it in the way it's supposed to go in? That would be just moving this over to here. Things changed, didn't they? Okay, so we're still sweeping. I'm going to tune the radio here a little bit. So still see the local oscillator, but there's other signals now on the SDR. Probably those are worth ignoring completely. Around 800. Ooh, what happened there? Ooh. We can be listening to this. Sounds like a radio there. What was that? Oscillator jumps. This lady radio's working. It's tuning stuff in. You're kidding me. Okay. So what I'm going to do now? I'm gonna. Okay, I like it on this side better. Ooh. We're gonna try and find out what frequency this thing is picking up. It's definitely doing something. Quiet down there. Oh, that's where the short is. Let's come up here in this sensitive area, right here. Okay, let's launch another signal at it. Out of there. What happened there? I touched something way over here on the far side of my bench in the radio. Oh, it did something, didn't it? And what was that sound? Is there a cat in here? No cat in here. I'm getting spooked out. I'm getting spooked out. Here we go. So on the end of this now is a signal. Let me put a coil on here. Kind of a silly coil, I feel like. I'm just going to hang this right around here. Oh, smokes, that shouldn't do that. What happened there? Must be... Oh, very, very loose connection there. Just hang there. Hang loose there. And now I'm going to stick a signal into that coil. Don't. Up where we think we're tuned. Should be maybe, I don't know, 600-700. I don't see it on that, so I should see this signal on the SDR. I don't see it anywhere. Am I doing something wrong? Signals are all up. Definitely a 680. I would like this to appear briefly on the SDR, so I'm going to move this over to where the SDR pickup coil is. There you can see it. For some reason you're seeing two of them. So that is at, well, it's rated 680. So it's definitely there. Put it back here. You know, I should really clip this guy right on and jam the signal in. Let's do that. Let's not fool around here. Let's get more brutal. I'm going to use one lead the ground off. Grab a clip lead here. put it on the grid of the first two. Before doing that, turn down that volume control over there. Grid of the first two. Now, do we see something at 680? Let me change the signal generator a bit. Yep, there it is. So there's our radio station coming in. And here's our local oscillator. Perfect. Okay, let's set this back up to 1,000,000. So 200,000, 800. 800. Well, you can watch it on the SDR as we come across. Here it comes. It's there. Now, something's there. I have my signal tracer up full, and the hum is just coming from the signal tracer itself. Tune back and forth across the 800. Hear it? But we're not hearing the demodulated tone. Not at all. Or are we? We are. It is there. It's just super duper faint. So am I kidding myself? I think this radio is receiving 800 kilohertz and actually managing to detect it ever so slightly. We're still injecting the signal after this stuff here. Okay, I gotta try tuning the transformers again. Might be noisy. Same spot. Next one. Go in the slot. There we go. Well, that sounded pretty good there for a moment. Okay, I think I know where I'm at here. At the point where this radio appears like it's ready to work, and there's probably all kinds of bad connections in it. I think I was just tapping on one of them. So the next stage is to clean up all these connections in here, make sure they're all good. That's a lot of effort, but I think that has to be done. Oh my gosh, that's a lot. Get them stable anyway, so we can continue. Interesting stuff. I can't believe it. It's almost working. Thanks a lot for watching, and be in here again tomorrow.